Good day everyone. In today's video, we are going to talk about the introduction under our next topic, which is all about your projectile motion. So before anything else, we have this set of objectives. First is to extend the definition of position, velocity, and acceleration to 2D and 3D using vector representation. Deduce the consequences of the independence of vertical and horizontal components of projectile motion. Calculate the range, time of flight, and maximum heights of projectiles, and solve problems involving two-dimensional motion in contexts such as but not limited to ledge, jumping, movie stunts, basketball, safe locations during firework displays. These are just some of the application of the concept. So first, we have to define motion. We all know that motion is all about your movement from a reference point to an endpoint. We have defined as well these two types, which is your one-dimensional and two-dimensional under the previous topics. So under one-dimensional, we have motions in a straight horizontal line and your free-falling body or the movement that is more on downwards. We also have two-dimensional here, which is all about your projectile motion and circular motion. But no worries, because we are just going to talk about these two highlighted things under this discussion. So first, let's define free fall. So when we say free fall, this is any object that is being acted upon by the force of gravity that is said to be in a state of free fall. So as long as the only force acting on it is your gravity and it's free falling, we consider it as your free fall. So under free fall, we have here Galileo that discovered that all falling objects accelerate at the same rate in the absence of air. So if you do a review for this one, we have Aristotle first. So Aristotle defined two types of motion, which is your natural and unnatural. So along with those concepts, he also discussed that heavier objects would fall faster. But since Galileo is eager to identify which of these two or if the statement is indeed true, so he conducted an experiment at the Tower of Pisa, and by then he discovered that Aristotle is wrong on that claim because according to Galileo, any object, or may it be different in mass, may it be different in size, they will fall at the same rate when we remove air resistance in the context. Okay? So two objects of different mass dropped from the same height will hit the ground at the same time. So of course, when we talk about air resistance, say for an example, a feather and a rock, of course, in day-to-day basis, the rock will fall faster, right? It's simply because the air is reacting on it, okay? There is a resistance. But when we try to remove this factor, we can see that your feather and the rock, okay, given that they are being thrown at the same height, they will fall at the same time. So when we try to undergo the problem solving, you have to take note of these two characteristics that are true when it comes to free-falling objects. So one, free-falling objects do not encounter air resistance, so we are more on the ideal, okay, because of two things. One, the first reason is that it is almost negligible, right, in day-to-day basis. The second is that we are trying to prove Galileo's claim. So all free-falling objects on Earth accelerates downwards. So this is your G, or your gravitational pull, which is your 9.8 meter per second squared, or often approximated as 10 meter per second squared. So when we talk about projectile motion now that we have defined what is free fall, generally, technically speaking, projectile motion is more on this game, right? So we identify, or we commonly see, or we can describe what is projectile motion by taking a look at your Angry Birds, okay? At the game Angry Birds. But if you take a look at this context deeper, if you are more on the physics aspect, you can see this set of formulas. So you have here your V of X and V of Y. You also have there your angles. As you can see, it forms there a trajectory line. Okay? It's a trajectory line, it's parabolic, which actually signifies your projectile motion. So projectile motion now then is an object upon which the only force acting is gravity. So technically speaking, this is now how we define projectile motion. But if you take a look at it, you will definitely parang see that it sounds familiar, right? So the definition itself sounds familiar simply because this definition under projectile motion is the same as the definition provided under your free fall. So what now could be the difference? So projectile is any object that once projected thrown at an angle that continues in motion by its own inertia and is influenced only by the downward force of the gravity. So we can therefore conclude that free fall is a special type of your projectile motion. So projectile happens when an object moves along a curved path under the influence of gravity. So take note that there is no other force acting on it aside from your gravity. So we also have here your vertical direction. So the vertical ones provides or commonly provides your angles. So it could travel this way, and at the same time it could also travel some distance in a horizontal manner. So projectile motion, when we combine these two aspects, we commonly have your parabolic paths. And these parabolic paths actually, although they are more on the relationship of your horizontal and vertical, these components are independent of each other. So meaning to say, whatever happens in the space where the object was thrown to create a projectile motion, it doesn't necessarily mean that the horizontal and the vertical movement are dependent with each other. So these are some examples of your projectile motion. So we have here archery. We also have your basketball, your baseball, jumping itself, or even your habit of throwing garbage on the garbage can, okay, trying to move like playing basketball. So this type of motions are examples of projectile motion. So there are three types. So the first one is, of course, your free fall, as what we have discussed earlier. So the left picture, as you can see, exhibits free fall. The middle one exhibits what? More on vertical, right? Vertical projectile. And then the last picture will be your horizontal projectile. So the two types of projectile that we will be talking about in computing is more on your vertical projectile, could be angled or not, and your horizontal projectile. So as you can see, what varies is the direction of the motion, right? So if it is moving upwards, going downwards, we can say it's vertical. If it is going from left to right, or vice versa, as long as it is being acted upon by gravity, so we have your horizontal projectile. So under trajectory, as what we have mentioned a while ago, so this movement or the movement of or the parabolic movement of your projectile motion is commonly called your trajectory lines or trajectory. So it's a flight path that is or that an object in motion follows through space as a function of time. So if you take a look at the components of the projectile, so you can see here the relationship of your x and y components. As you can see, we have points A, B, C, and D. So if you take a look at it, the most important thing is that you have to notice that on C, okay, sa C, wala na tayong y component, right? Wala na tayong vertical component simply because it is now the maximum. Okay? Meaning to say, wala na siyang itataas pa. So that is the maximum vertical movement. And then we have here this analyzation, of course, that the movement from point A, B to C is lower. Right? Even if we try it in our homes, if we are trying to throw something opposing the pull of the gravity, it's moving slowly, okay, compared to those movements that are following the direction of your gravity, which is 9.8 meter per second squared, that is exhibited in your points D and E. So you might wonder as well as for the signs. So para hindi malito, it's just simple. Just put on a Cartesian plane, putting the object at the origin so that you can definitely tell in which direction it goes. So say for example, your A, you can see that the V1, okay, the direction that it is going is positive, right? Simply because this is now your, you can imagine here a Cartesian plane and it is moving towards the quadrant 1, right? So same with D, tignan nyo yung D. So it moves to quadrant 4, right? So it's a negative y and a positive x. So you imagine there are Cartesian plane, kaya magiging negative ang y component natin. Okay, so I hope we are all clear with this one. So vertical component is only affected by the gravitational pull or your gravity, while the horizontal component is more on inertia. Ano nga ulit yung inertia? An object that is moving will continue moving, and an object that is at rest will remain at rest unless acted upon by external forces. So horizontal component is a uniform motion. You might wonder why it is called uniform motion. The answer is on the next slides. And then your vertical component is uniformly accelerated kasi nga the gravity has a uniform acceleration of 9.8 meter per second squared. Okay, so as simple as that. So the initial velocity if given, therefore you can compute for the height and the range of your projectile. But there are some problems under the problem solving that doesn't necessarily contain your initial velocity. Okay? But you don't have to worry about it because it will be discussed to you by Ma'am Mars. So understanding the kinematic equations, so take a look at the two objects there. You have the yellow ball and the red ball. So the question now is, which ball will fall faster? The red or the yellow one? Feel free to pause this video and take some time to think about your answer. Okay? So the answer for this question definitely is, they will be falling in the same rate. Okay? According to Galileo, they will be falling at the same rate. You might wonder why. This is now where the explanation under the uniform motion in the horizontal or the x component lies with. It just means that regardless of the movement, okay, the movement or the horizontal motion is actually constant. Okay? And it doesn't necessarily affect the gravity. Kasi nga, we have already identified that the x component and the y component are not independent with each other, or not necessarily parang taking an effect with each other. So we can express that all the vector relationships for this projectile's position, velocity, and acceleration by separate equations for the horizontal and vertical components. So I think that's it for the introduction.